Welcome back, chemistry fans. We are going to deal with Unit 8 exam, the multiple choice questions. So let's jump into it and let's start putting the solutions together. So in this first question, we are dealing with, again, solutions, but this first question is actually the M1, V1, the dilutions, but it's without the math portion of it. So what we're asked to do is just to figure out how we're going to put this together into a formula. So what you would need to know is that these combine together already. So and then where we started, though, is this right here. But what we need is 0.5 liters is what we've got to get. So to this 6 molar, we've got to turn it into a 0.15 molar. So to do that, we're actually going to have to dilute this. So we need to get our math together and solve for this. Well, I've got to get myself a calculator, and then we'll do that. Okay, so here we are. So to solve this, I'm going to multiply 0.5 times 0.15 equal to 6 times this new volume, which I don't know what that is. So I'm going to do 0.5 times 0.15 divided by 6, and I end up with 0.0125 of the 6 molar stock. So what that means is that's in liters, so I'll multiply that by 1,000, and I get 12.5 milliliters is what I need of the 6 molar, and then I fill it up until it hits that same amount. So the one that talks about that is right there on number 2. Second choice down. All right. Moving to question number 2. Which of the following can you expect to be the most soluble in hexane? All right, so let's jump into this. Hexane is very, very non-polar. It is symmetrical and on top, and if we cut it down the middle, the left looks like the right, the top looks like the bottom. So we've got to find some molecule that looks the exact same way. Well, if I'm looking at this, the top does not look like the bottom. The left does not look like the right. The left does not look like the right, nor does the top look like the bottom. This is the only one that if I cut it, it's going to be the same throughout. And they have similar polarities. So that would be my answer, C6H6. Okay. Now moving to question 3. Question 3, let me move me out of the way. Question 3 is asking, to make a solution of 3.45 moles of a solid and 116 grams of a liquid are mixed, what data is needed but not given in this problem to calculate the molarity? Okay, so we have the formula molarity is equal to moles over liters. So I have what I need for moles right there. 116 of liquid C6H12. So what we have, we don't know how to convert that into liters. So we would need the density of this C5H12 to convert grams into liters. We don't have any way to do that. Now, what we could do, though, is figure out the density of this entire solution, because what liters is, it's not of the liquid, it's the liters of the solution. So that's where our answer comes in, is B on that one, knowing what the actual definition of molarity is. It's moles of liters, or moles of solid divided by liters of the solution. All right, number 4, which of the following mixtures is heterogeneous because the substances do not mix? Well, that is oil and vinegar. Same thing as oil and water. They do not mix. That makes them immiscible. All right, let's cancel this one out and let's move to question number 5. Question number 5 is one of our graphs, and it's asking us on this graph, which answer is unsaturated for KClO3. So let's find KClO3 first off. KClO3 is this line right here. And so we're finding one that would be below this line, something that's below this line. So 60 degrees, 10 grams, that is below the line. At 20 degrees, 10 is on the line. At 80 degrees, 45, it is above the line, it looks like. So that's not going to qualify. And then 40 degrees, 20 grams. 40 degrees, 20 grams, that's also above the line. The only one that is below the line is that very first one at 60 degrees, 10. All right, so that takes care of question number 5. Let's move on to 6. And it's another one of these graphs. And what they're asking us to do on this one, maximum amount of KCl that can dissolve in 200, not 100. So KCl, let's find that line. KCl, it is a straight line going up right here. What's the maximum that can dissolve at 75 degrees? So find your 75, go straight up, and it looks like we're just on this line somewhere around 50, but this is for 100 grams. So we would need to double that to make that 100 grams, or roughly close to that somewhere. So if we're looking, here's our answer, 100 grams. All right, so that takes care of 6. Now we can move to 7. Question number 7, temperature dependent. Which one has a significant effect on the solubility of all gases as they are dissolved into liquids? So some solids actually do not have much of an effect. So the significant effect is whenever we have gases, all gases are significantly affected, always. And number 8. What type of solution is a 49.0 gram sample of potassium nitrate dissolved into 100 grams of 100-degree water? Precautions are taken to avoid evaporation. The solution is cooled to 30 degrees and a precipitate is observed. So what type of solution is it once I have now got a precipitate in it? Well, that means it was supersaturated. If it has a precipitate, it is supersaturated. All right, so that takes care of question 8. Let's jump on to 9. And it is solubility rules that we're going to deal with. So we're trying to figure out what it is. So I've got Na2SO4. Here is SO4, and it is clearly going to be soluble. There are no exceptions over here for it. All sodiums are also going to be soluble. So you've got 2 things telling you this is soluble, no exceptions, no precipitant. So it is soluble and does not produce a precipitant. That is very abundantly clear on that one. So let's jump to question number 10 now. Let's see if it's equally as abundantly clear. Question number 10, let me bubble it up here a little bit. It's larger, blow it up rather. NH4CO3. All right, there are no rules for NH4. There is a rule for CO3. CO3 does have an exception, so that does make it soluble. And that means that it has no precipitant. It is soluble and it does not produce a precipitant. So that is the exception to that rule. All right, so we are finished now with our multiple choice, I believe. Yes, we are finished with multiple choice. So thank you very much for watching. I will conclude the free response on the next video. Thank you. Talk to you again soon. Bye-bye.